everyone. In this particular video lecture, we will discuss parallel resonance. Now, my dear friends, this will be basically the last lecture, or we can say last topic of Unit 2. Now, first of all, we will discuss what is parallel resonance. Now, my dear friends, as you can see here, in the same way as we discussed series resonance, where all the elements basically RLC are connected in series, that is end to end. Now, in this particular section, we can see that all the elements are connected in parallel to each other. Now, as you can see here, basically there are three elements: resistor, capacitor, and inductor, and there is a supply source which is denoted by V, and the current flowing through all these elements are mentioned here. Now, as you can see here, first of all, we will calculate the basically admittance, that is Y. Now, if you want to calculate the equivalent admittance, that is Y, then it will basically equal to, we can say, Y1 plus Y2 plus Y3. Now, we know that basically Y1 is equal to basically G, which is equal to, this is basically conductance, which is denoted by G, and G is equal to further 1 by R. Now, Y2 will be equal to, in case of inductor, it will be equal to 1 by plus JXL, and Y3 will be equal to minus 1 by JXC. Now, if we put all these value in this equation, then we will get the equation 1 by R plus 1 by JXL minus 1 by JXC. Now, from here, as you can see here, if we common J minus J, then our equation will be basically equal to 1 by R minus J into 1 by XL minus 1 by XC, as you can see here. Now, for a resonance, we know that basically the we can say imaginary part, or the net we can say susceptance or admittance should be equal to 0. So this will be basically our net admittance or susceptance, we can say. So here we will equate this to 0. As you can see, our 1 by XL minus 1 by XC is equal to 0, and from here we will get XL is equal to XC. And my dear friends, if you have remembered, then this case was basically similar. This case was basically same in case of series resonance. Now we know that, my dear friends, omega L, from here XL is equal to omega L, and we know that XC is equal to 1 by omega C. And from here, if you want to calculate the value of resonance frequency, then its value will be equal to 1 by 2 pi root under LC, and F0 is basically the resonance frequency, we can say. So, my dear friend, in case of parallel resonance, the value of basically resonance frequency will be equal to 1 by 2 pi root under LC. Now, as you can see here, as we proceed further, then in case also, my dear friends, the value of phi, that is power factor angle, will be 0 degree, and here the same case, that is the circuit will be have as a resistive circuit, and so here the power factor will be the cos phi, that is equal to 1, that is unity power factor, same as that of resistive circuit. Now we know that basically Y, that is admittance, is equal to G plus minus JB. Now, as you can see here, basically this is our admittance, this is conductance, and this is basically susceptance. Now, for RC circuit, we will use, for RC circuit, my dear friends, we will use basically plus here, and for RL circuit, we will use minus here, as you can see here. Now, as you can see here, G is basically the conductance, and its value is equal to 1 by R. B is basically susceptance, whose value is equal to 1 by admittance, and Y, admittance, is basically equal to 1 by Z, that is 1 by impedance. Now, this was now we will discuss the next topic, that is the circuit diagram for practical parallel resonance circuit. Now, my dear friends, this is basically we can say, this is basically the circuit diagram of, as you can see here, as you can see here, my dear friends, this is basically the circuit diagram of practical parallel resonance circuit, or we can we also called it as a tank circuit, as you can see here. Now, as you can see here, basically this series combination of this resistor and inductor is connected in parallel with the capacitor. Now, in this case, if you want to calculate the value of admittance Y1, then it will basically equal to 1 by Z1, and as you can see here, basically Z1 for this combination of resistor and inductor, as you can see here. Now, Z1 will be equal to R plus JXL, and if we rationalize this value, then it will basically equal to, as you can see here, Y1 will be equal to R by R square plus XL square minus JXL by R square plus XL square. Now this is basically the value of, we can say, y1. Now if you want to calculate the value of y2, then as we know that y2 basically only capacitor is connected, so here y2 will be equal to 1 by z2, and 1 and the value of z in case of capacitor is basically, we can say, minus jxc. So here 1 by z2 will be equal to minus 1 by jxc, and if we send this j to the numerator, then it will basically equal to j by xc. Now if you want to calculate the total admittance, that is y total, then as you can see here, its value will be equal to, y total will be equal to y1 plus y2. Now if you put all these value, then as you can see here, our equation will be basically of some will be comes out to be, as you can see here, y total is equal to r by r square plus xl square plus from this equation, my dear friends, we have taken plus j as a common. So then so our equation basically becomes 1 by xc minus xl by r square plus xl square. Now my dear friends, as at resonance, as we know that the net reactance, or we can say the net admittance or susceptance is equal to 0. So here the net susceptance, and my dear friends, as you can see here, this is basically the net susceptance. So here we will equate this value to 0, and as we will equate this value to 0, then as you can see here, our equation will be something of this type: 1 by xc minus xl by r square plus xl square is equal to 0. And now as you can see here, further our equation becomes, if we send this term to the right hand side, then it will be basically 1 by xc is equal to xl by r square plus xl square. And now if we do cross multiplication, then xl into xc is equal to r square plus xl square. And now if we put all these value here, then as we know, xl is equal to omega naught into L, and we know that xc is equal to 1 by omega c, and here the value of r square plus xl square is omega L whole square. Now if we calculate all this value, then our basically equation will be equal to omega square is equal to 1 by lc minus r square by L square. Now my dear friends, if you want to calculate the value of omega naught, that is, we can say, angular frequency, then it will basically equal to root under 1 by lc minus r square by L square, and its unit will be basically radian per second, as you can see here. Now if you want to calculate the resonance frequency in this case also, so we know that basically omega naught is equal to 2 pi f naught. So here we have put the value of omega naught, 2 pi f naught is equal to the RHS side will be basically equal to root under 1 by lc minus, there is root under 1 by lc minus r square by L square. There is no change in this value. And so here if you calculate, then our value for resonance frequency will be equal to 1 by 2 pi root under 1 by lc minus r square by L square. Now my dear friends, as you can see here, if we proceed further, then we will basically draw the graph between susceptance and frequency. Now we know that basically there are two types of substance. The first one is we can say inductive susceptance, as you can see here, which is denoted by BL, and the second one is we can say capacitive susceptance, which is denoted by BC. Now we know that BL is equal to 1 by JXL, and if we send this j to numerator, then our equation will be minus j by xl, and if we put the value of xl, then it will be minus j by 2 pi fl. So from here, if we write, then we can say that BL means inductive susceptance is directly proportional to 1 by f. Now in case of, my dear friend, capacitive susceptance, we can say that BC is directly proportional to f. Now if we draw the graph, then our graph will be something of this type, as you can see here. Then my dear friends, our graph will be something of this type, as you can see here. This is basically the frequency axis, and this is basically the we can say susceptance active. So this is basically this show that BC is directly proportional to f, and this shows that basically BL is inversely proportional to f. Now my dear friends, this point basically indicating resonance frequency. So if we talk below resonance frequency, basically, as you can see here, below the resonance frequency, the value of we can say inductive susceptance is greater than capacitive susceptance. So here the circuit will basically behave as RL type circuit, and will be lagging in nature. Now if we talk to the frequency greater than resonance frequency, then in that case basically the value of BC will be greater than BL, and means it will basically RC type circuit, and so it will be leading in nature, my dear friends. So this is this the diagram is very important from the competition, or we can say semester point of view, because directly objective questions are asked from this diagram, that what will be the nature of circuit, we can say below resonance frequency or above resonance frequency. So below resonance frequency the circuit will be basically lagging in nature, and below or we can say above resonance frequency the circuit will be leading in nature. Now my dear friends, we will move to the next most important point. As you can see here, at parallel resonance the value of net susceptance becomes 0, and admittance is basically equal to conductance, as you can see, as you can see in the previous derivation. And my dear friends, reactive or weightless component of line current is 0, as you can see. And now at the parallel resonance line current is minimum and in phase with voltage. And the next important point is power factor is unity in case of parallel resonance. Now as you can see here, at parallel resonance condition the net impedance is maximum, my dear friends. In case of parallel resonance, basically the net impedance is maximum, so current is minimum, and it is called as a rejector circuit. Now at parallel resonance frequency the total current flow through resistor, and hence it is called current amplification circuit. Now my dear friends, in case of we can say parallel resonance, basically the total current flows through resistor, and hence we can say it as a current amplification circuit. Now we will move to the next we can say topic, that is quality factor. We know that, my dear friends, quality factor is equal to energy stored by energy dissipated, and by keeping this equation in mind, we will basically calculate the value of energy in case of RL circuit and in case of RC circuit. So in case of RL circuit our equation will be somehow equal to R by omega L, and in case of RC circuit our equation will be comes out to be omega into LC, as you can see here. Now if you further calculate, then we know that omega square is equal to 1 by LC. So the value of omega will be 1 by root under LC, as you can see here. And here also we have put the value of we can say basically we can say the value of omega that will basically equal to 1 by root under LC. Now my dear friends, after calculating all these value, we can say here the value of quality factor will be equal to R into root under C by L, and this formula will be very important from an objective point of view, because the value of resistance, capacitance and inductance will be given in the question, and we have to basically use this formula, and we have to calculate the value of quality factor. So we must have to remember this formula. Now we will move to the next and the last topic, that is the we can say comparison between series resonance or parallel resonance. Now as you can see here, basically if we talk regarding the impedance in series and parallel resonance, then in series resonance the value of impedance is minimum, and in case of parallel resonance the value of impedance is maximum. And if we talk regarding the current, then current will be equal to in case of series I is equal to V by R, and in case of parallel the value of current will be equal to I is equal to V by L by RC. I know, my dear friends, if we talk regarding the effective impedance in case of series resonance, then it will basically equal to R, and in case of parallel it will be equal to L by RC. And if we talk regarding the power factor, then as we know that in both the cases the power factor will be unity power factor, and it will be equal to 1. And if we talk regarding the formula of we can say resonance frequency, then in case of series resonance it will be basically equal to F naught is equal to 1 by 2 pi root under LC. And in case of, my dear friends, parallel circuit, as you can see here, the resonance frequency will be equal to 1 by 2 pi root under 1 by LC minus R square by L square. And now if we talk regarding the voltage, if we talk regarding the magnification, then series resonance circuit basically behaves as a voltage magnification circuit. And if we talk regarding the parallel resonance circuit, then parallel resonance circuit basically behaves as a current magnification circuit. Now my dear friends, this was all regarding the parallel resonance. I hope you have enjoyed this video. That's all. Thank you.